Hi, my name is Mike Medding, and I'm doing this quick little screencast for my project for Anna Rumshiski's NLP class, fall 2015, and it's to go over a program which detects Twitter, or bullying in Twitter. Go through some of the files that we have here. This is the main project directory. Pretty much everything is all right here. Just go through each one of the folders really fast, and then kind of show what the lexicons look like, and then go quickly through some code. Each one of these folders is a different feature. So tagged POS data, Twitter bullying analysis, and part of speech tagger, those are all arctweet features. Subjectivity is also arctweet. Senti WordNet corpus is how we based our sentiment analyzer. Harvard Inquirer is to then improve that sentiment analyzer. And then we have our corpus. And I'm going to go ahead and show you what corpus looks like. We have been working on building a corpus, which we had to compile by hand, which is done, or which looks like... Oops. This is what our corpus looks like after it's been fully processed and collected and everything. This is, it's pretty straightforward. It's tab-separated values with the user, the tweet that they had, and then what we tagged it as. And for this one, we can't... Oh, actually, here's one. This is a tweet that was manually tagged as bullying. So that's kind of what our compiled corpus looks like. Quickly show what... So if we go into... search term lexicon. This is some of the lexicons that we used in order to try and develop some of the features that were used in this program. There we go. This is one of them called the emoticon lexicon. Basically, it just says positive or negative emotions using emoticons. Searches for those in Twitter and decide, or it helps to decide whether or not that's a bully. Let's see, hashtag sentiment. This is how we developed the search terms in order to be able to scrape Twitter for the data that we used in order to be annotated for this project, which is this unigrams lexicon, which is just words which have been tagged with a sentiment score based on Twitter data, so essentially the Senti WordNet, but trained on Twitter data specifically. Went through all this whole file and pulled out the words that had high negative sentiment, so anything that had a negative sentiment of -4 or less we used for search terms, and I believe there's about 2,500 of those specific search terms which were tagged as being negative terms in Twitter. In addition to that, once we had put together all of those search terms and then went and scraped Twitter, we ended up with our gold standard corpus, which was to be then manually annotated, which I just showed, the combined file, which, as you can see, is, as of right now, 3,027. I actually have 1,000 more I need to add to that. So about 4,027 tweets that have been annotated that we're using for running this program. And now I have already gone ahead and run this program right here. The meat of this program is really centered around ML test, which is it started off obviously as a machine learning test file, but basically it's just incorporated the entire project at this point because we had to do this so quickly. But essentially, starting from the top, it enables, or it initializes all of the different features used for tagging and can't even talk today, for analysis. Can see there's the part of speech tagger, the sentiment model, Harvard Inquirer, all of that stuff is all in here. This is where it parses all of the data combined. These are a couple of extra little ones, and after it's gone through and parsed all the data, and this also part of speech tags it, it splits out this data into a test set and training set, which is just randomized at like 20 to 30% of, or testing is 20 or 30, and then training is the other half, or the other percentage of that. And then it all gets thrown into extract features, which you can see here. Goes through using all of those initialized objects and extracts all of its features for its machine learning algorithm. Let's see, extract features, then it... Yeah, so this is pretty straightforward. Oh, and then it gets obviously shoved into a minor little machine learning algorithm, which uses... see if I can explain this. It uses... But, sorry, I didn't want to give you bad information. It uses a neural network in order to analyze the tweets and learn from the tweets that it has already seen. And after going through and running this, we can see, I just did this output a few seconds ago, results from the training set obviously are pretty good because that's what we're training off of, and then completely unseen data testing results, I mean, that's 21% precision, 15% recall, so the recall isn't great, but I've had this thing, after running it a couple of times and adding a little bit, I've been into almost 30% range, so that's significant. It's not great, obviously, but when we're looking at data that's so sparse, especially because this entire test set, there were 5 bullying tweets that were correctly tagged to a false positive, so tweets that were tagged as bullying that really weren't bullying 18 times, so, but over, what is this, 553 tagged tweets, that's not too bad. Getting 5 correctly, I mean, even if we looked through, 20 or so tweets, we'd still be able to quickly decide, especially as a person, whether or not that person was a bully. So it would narrow down the data we'd even have to look at for looking for bullies exponentially. And yeah, that basically explains it. All the rest of the features in here, like pattern extraction is right in here. It's quick little files. A lot of these were just quick little files that were grabbed from either sentiment features or from this project ArcTweet NLP, which is all detailed in the paper. Yeah, there's the emoticon lexicon, Harvard Inquirer. Each one of these packages is a different feature, and then Twitter bullying analysis is where we wrote all of the test files. So ML test is, like I said, the main file. The rest of these can be used for analysis, and in Twitter data mining, there's the Twitter consumer. This is the actual data mining setup, which goes through, parses that lexicon file, scrapes through Twitter, creates that raw tweet file that we use for analysis after it's been annotated. And yeah, that's basically how our program works. I hope this wasn't too long, and hope this makes it a little bit easier to grade and understand. Thanks for listening.